Swayam Prabha. Digital India. Educated India.
Welcome back to lecture number 27, part 2 on the topic cold chain. So, just before this one, critical and effective temperatures, we were discussing about, I was explaining about the concept of product, process and packaging. So, what kind of product that is produced and what are all the process techniques that were employed and and the kind of packaging techniques also, methods that were used. Next one is a comparison between critical and effective temperature. So, the effective temperature is the temperature, let us see the first critical temperature. It is the temperature which is required to maintain the quality of the product. Specific temperature range that is required to maintain the quality of the product. Most of the positive temperature applications product requires a temperature of say 2 to 8 degrees centigrade. We can take up to 10 degrees, that is less than 10 degrees centigrade. Products such as pharmaceuticals, food, vaccines during storage and transportation. Effective temperature, it is the temperature that is, it is the actual temperature that is experienced by the product. At different points within the cold chain. Especially when the product is transported in the truck, especially when the truck is shifting the product, transporting the product for a long distance from one city to another city or even from one state to another state. So there are chances that the ambient conditions could vary. Next one is a very important aspect in cold chain, that is temperature monitoring. Temperature monitoring. It is a process, as the name indicates, it is a process of manually monitoring the temperature and periodically recording the temperature. If it is not done, there are chances that the system may not be functioning properly, which would affect the quality of the product which is in the stored environment. It's a process of tracking and managing the temperature sensitive products from storage to delivery. A lot of instruments are available, like different temperature measurement sensors, indicators, data loggers, etc. So this will help to reduce the wastage, spoilage, improves the quality, extend the shelf life. Those are all the advantages of having this temperature monitoring. Improved product quality and safety, enhanced efficiency. Transportation. So this is a very important one. Direct delivery from farm to market. It is done with the help of a truck, refrigerated truck. Suppose if the product need to be transported within the city, then a small type of van. Within the city, small type of van. Intercity, there is mostly long distances, depending upon the distance, or moderate distances. Highway, truck or rail carriage, and very long distances, or especially from one zone of the country to another zone or between two countries, marine, long distances between countries, marine container, refrigerated air cargo container. The mode of transport is through sea or air. Classification of refrigerated trucks based on internal box volume. If the volume is in the range from 8 to 10 meter cube, it is classified as minivan. Light commercial vehicle, that is called LCV. Light commercial vehicle is called LCV. High commercial vehicle, 25 meter cube. I would like to emphasize one point, especially in this cold chain, in the part 1 lecture, in the part 1 of the lecture number 27 and this lecture. Most of the topics, most of the points which are mentioned in this slide are self-explanatory, like one can easily understand going through this one. So this is like one will be able to learn at a self-paced mode itself, but still wherever some important points are there, I am just explaining. Otherwise, I will just quickly run through this topic. Selection of transportation vehicle, make and model, which company, which brand, what is the model number, maximum external dimension, that is what is the length, width and height of the vehicle allowed as per RTO rules. So these are all the, one cannot design the refrigerated truck or a refrigerated van as per his or her wish. There are guidelines, there are standards put forth by the RTO department. Weather data, when we say weather data, it is the dry bulb temperature, wet bulb temperature, relative humidity, etc. Size of the box, inside temperature of the product to be loaded, what kind of product to be loaded, is it a single product or a multi-product? If it is a multi-product, whether the storage temperature required is whether the required storage temperature are same or different storage temperatures, temperature to be maintained inside the vehicle, duration in hours of product storage. It could be in terms of days also, distance. Next one, continuing with this one, time required to load and unload the vehicle. So time required to load the products in the vehicle and unload the products from the vehicle. Location of the door, whether the door is located on the rear side, that is on the back side, or on the side. So this is the side, door on the side. In this vehicle, the door is on the side door. This is the side door and this is the rear door. Size of the door, the dimensions of the door, length, width and height. Electrical standby. As I said before, there are some regulation standards as per the agreement on transport of perishable, that is ATP, agreement on transport of perishables. These are set of standards and regulations for the construction and use of insulated body and refrigerated equipment. Vehicles are classified as from class A to class F. In that class C and class F, if the temperature is less than 20, if the temperature is negative, that is below 0, up to say between -10 and 0, the vehicles are classified as class C and class D. And if it is less than, the temperature is less than very low temperature, lower than -10 degrees centigrade, then the vehicle comes under the class B and class E. Vehicles are certified periodically and stamped for proper identification. Recommended overall heat transfer coefficient, that is the U value in watt per meter square, degree centigrade or Kelvin, as per ATP regulations. So the transportation, so if the temperature is -25 degrees centigrade, the U value is 0.29 watt per meter square, degree centigrade. These are all the values of U, overall heat transfer coefficient, overall. And if it is at minus 20, the value increases from 0.29 to 0.32. Then transportation from 0 to 80, that is 0.4. Factor of safety of 1.8 to 4.5 to be considered for transport refrigeration, depending on the product and the temperature at which it is stored and transported. So the transportation regulations as per this ATP. So I have little ago we have seen the classification according to the internal box volume. So small vehicle, light commercial vehicle, and heavy commercial vehicle, not high, heavy commercial vehicle. So internal volume meter cube. In case of small vehicle, it is from 10 to 12 meter cube. LCV is 18 to 20 and HCV is 25 to 30 meter. Temperature to be maintained inside, this is minus 20. I have made a comparison by taking a reference temperature of minus 20 degree, which has to be maintained, and comparing the dimensions, the vehicle length, the internal volume of small vehicle, LCV and HCV. The above capacities of the vehicles are based on an ambient temperature of 35 degrees centigrade and one door opening per hour. That is, for every 1 hour, the door is open only once. So I have taken as like a kind of a case study, a small solved example. The vehicle make is Tata. Pre-cooled product temperature is minus 25. Outside dimension of the vehicle body is length is 4.2 meter, width is 2.1 meter, height is 1.8 meter, volume is 18 meter cube. Single door is used on the rear side. Insulation is polyurethane foam, that is puff. Insulation thickness 150 millimeter. Thermal conductivity is given as 0.4 watt per meter square watts per meter degree centigrade. For thermal conductivity, the unit is watt per meter Kelvin or watt per meter degree centigrade. Dry bulb temperature 45, relative humidity 95, product ice cream for local delivery, box color is white. So estimate the heat load. So first let us calculate the external area. External area that is equal to 2 into, the dimensions are given, length into width into height. So 4.2 into 2.1, 4.2 into 2.1, so it's like this one, L into W plus W into H plus L into H. So 2 into 4.2 into 2.1 plus 2.1 into 1.8 plus 4.2 into 1.8. If you calculate when the external area, it comes to 40.3 meter square. 40.3 meter square. Now the internal area is calculated. By subtracting the thickness of the insulations 2 into, so insulation thickness is given as 150 millimeter, that is equal to 0.15 meter, 0.15 meter. So on both sides, so you will get, instead of 4.2, 3.9 into, instead of 2.1, 1.8, 1.8, and instead of 1.8, it will be 1.5, 3.9 into 1.5. So this is the internal area. 3.9 into 1.8 into plus 1.8 into 1.5, 3.9, 31.2 meter square. That is by subtracting the thickness of the insulation on both sides. 31.2 meter square. Average area, that is external into internal area, square root. Or it is called the net area, square root of external area into internal that is equal to square root of 40 point, internal area is 31.2, 40.3, 40.3 into, this is the external area, this is the internal area, 31.2. Let me write it clearly. So it comes to, multiply and take the square root, 36.3 meter square. The heat load is UA delta T into safety factor. Heat load is equal to UA delta T, that is, instead of U, K is there, A into delta T into safety factor into safety factor. K is given, this is the value of K, thermal, this is the value of K, it is given. Delta T, we know the temperature difference, 45 minus of minus 25, that is outside temperature, this is 45, and inside, that is minus 25. So delta T is equal to 45 minus of minus 25. And area is the average area. So this is equal to 0.4 into, this is the average area. This we have calculated 36.3 into delta T. (45 minus 25) into safety factor is, so the factor of safety to be taken in the range from 1.8 to 4.5. I have taken close to 2, which is 1.95. This is taken 1.95. The range is 1.8 to 4.5 is the range. 1.95. So the heat load comes to 1.98 kilowatts. 1.98 kilowatts. It's a small numerical question which I want to. Role of packaging. So the packaging plays a crucial role in ensuring the safety and quality of temperature sensitive products. It helps to maintain a constant temperature range. It helps to maintain the quality of the product. It extends the shelf life of the product, reduces the cost due to wastages, etc. Specialized materials and technologies are used. Packaging components, insulated container, gel pack or ice pack, PCM. PCM stands for phase change material, and thermal liner. Packaging materials, paperboard, jute, fiberglass, EPS, expanded polystyrene, polyurethane, textile polythene, polyethylene. Controlled atmosphere. The ripening process can be reduced either by reducing the oxygen content or increasing the nitrogen content in the atmosphere. Process of controlling the atmosphere to the desired level, it is termed as controlled atmosphere. Controlled atmosphere machinery functions: removal of ambient oxygen, removal of CO2 produced by respiration, addition of air to replace oxygen consumed by respiration, and removal of C2H4 and addition of CO2, that is ethane. C2H4 is ethane. In the controlled atmosphere storage, normally oxygen content is reduced and maintained at 2% level. Too low oxygen level concentration below 1% will result in suffocation of products due to lack of oxygen. In one of the earlier lectures, I was discussing about the external factors which affect the shelf life, in which one of the extrinsic factor is packaging. So the gases which are present under the packaging material, it plays a crucial role. Oxygen, if you have carbon dioxide, then there are chances of preventing the microbial growth, whereas if you have more oxygen, there are chances of promoting the bacterial growth. Too high concentration of carbon dioxide will also cause suffocation because products will not be able to emit CO2. Recommended condition for most of the products are 3% O2 oxygen and 3% carbon dioxide. Controlled atmosphere packaging has been in use for bulk storage for nearly 100 years. Modified atmosphere. When the product is packaged, it creates a modified atmosphere. As the name indicates, the modified atmosphere is created. A modified atmosphere is created and increases the carbon dioxide percentage without any control. This process is termed as modified. Composition of air surrounding the food in the package is modified to reduce the rate of biological process in the food. That is to reduce the rate of microbial growth. To reduce the rate of microbial growth. To reduce the rate of microbial employed to extend the shelf life and quality of the processed food products. The methods of modified atmosphere packaging. One such method is vacuum packaging. Vacuum is removal of air from the system, from the packaging before it is sealed. In flushing, there is another method that is called flushing method. Air inside the package is replaced by inert gas, that is nitrogen, or a mixture of nitrogen and carbon dioxide. Come to the last topic in the last module, thaw indicators. These thaw indicators are labels, or printed form of labels, or self-adhesive labels. When a product has been exposed to temperatures above a specific threshold, potentially causing it to thaw or become unsuitable. Like these labels indicate when a particular product is not suitable for particular usage, or this one. Those are indicated in the form of labels, which could be a self-adhesive label or a printed label. They change the color or display a visible indication when the temperature threshold is violated. So when there is a deviation from the recommended storage condition, or any other, when there is any deviation from the standards, so these labels, either the color of the label is changed or they indicate in the form of a display. These indicators are designed to be irreversible. Once the color has changed, it is not possible to revert back to the original color. It's an irreversible process. So this is the picture of the thaw indicator. Before I conclude this lecture, so I would like to mention that this is the last topic in the last module. That is, the thaw indicator is the last topic in the last module, cold chain. To summarize the refrigeration cold chain management, the course comprises of 5 modules. We have studied about the principle of refrigeration, the fundamental concept of vapor compression refrigeration cycle, how to evaluate the coefficient of performance of the vapor compression refrigeration system, The processes have been plotted on pressure enthalpy chart and temperature entropy diagram. We have seen the applications of refrigeration in the first module. In the second module, we have discussed about the major components of the vapor compression system, that is compressor, condenser, expansion device and evaporator, the construction of each of these components along with the working principle, and to make the learners to have some interest towards these theoretical portions, I have introduced numerical questions, solved quite few examples in all pertaining to these four components. And in the third module, we have studied about the refrigerant classification, advantages, disadvantages of different kinds of refrigerants. How does the refrigerant affect the environment? Most of the refrigerants are not environment friendly. Then in this second half of the third module, we have studied about the heat operated vapor absorption system, triple fluid absorption system, that is the electrolytic refrigeration system, the performance evaluation of vapor absorption system, and simple numerical questions also in module number 3 pertaining to vapor absorption system. Module 4 deals with the shelf life of the product. How to extend the shelf life of the product? What are the different models pertaining to food deterioration? That is kinetic model, Q10 model, time temperature tolerance, triple T model, etc. And also we have discussed about the storage design requirements. When it comes to the storage design requirements, like what are all the various components of the heat load? We have seen transmission load, occupancy load, product load, infiltration load, equipment load, lighting load, etc. Then I have designed the cold storage for positive temperature applications, 2 numerical questions, and the negative temperature applications, 3 different numerical problems. And in the last module, we have discussed about the importance of cold chain, need for cold chain, the concepts of just-in-time, product process packaging, temperature time indicator, the importance of temperature time, monitoring the temperatures, packaging, what are the methods of packaging, what do you mean by controlled atmosphere, modified atmosphere, the difference between controlled atmosphere packaging and modified atmosphere packaging, and finally the concept, what is the use of this thaw indicator. So with this, the entire syllabus in the course cold chain refrigeration cold chain management has been completed. Thank you.